Hello friends, welcome to our YouTube channel. Today we shall solve a couple of tricky numerical problems on series RC circuits. In these problems, the values of resistance or capacitance will not be given directly. We have to determine the values from the other data provided. Problem number 1. A circuit comprises of a resistance R and a capacitive reactance of 60 ohm connected in series. We have to determine the value of R, for which the power factor of the circuit will be 0.8. Let us list the data provided. Capacitive reactance Xc equals to 60 ohm. Power factor of the circuit cos phi equals to 0.8 leading. Let us first determine the power factor angle. Phi equals to cos inverse 0.8, that is equal to 36.8699 degree. Now we shall draw the impedance triangle. From impedance triangle, we get tan phi equals to Xc by R. Therefore, resistance R equals to Xc by tan phi. That is equal to 60 divided by tan of 36.8699 degree. That gives us 80 ohm. Problem number 2. A resistor in series with a capacitor absorbs 10 watt when the combination is connected to a 120 volt 400 Hz supply. If the power factor is 0.6 leading, we have to determine the values of the resistance and the capacitance. Let us list the data provided. Supply voltage V equals to 120 volts. Supply frequency F equals to 400 Hz. Power absorbed P equals to 10 watt. Power factor cos phi equals to 0.6 leading. Therefore, sin phi equals to 0.8. We know the expression for the power absorbed P equals to VI cos phi. Therefore, expression for circuit current I equals to P divided by V cos phi. Putting values, we get 10 divided by 120 into 0.6. That gives us 0.1389 ampere. Let us determine the value of impedance. Z equals to V by I. That is equal to 120 divided by 0.1389. That gives us 864 ohm. Now we shall draw the impedance triangle. From impedance triangle, we get resistance R equals to Z cos phi. That is equal to 864 into 0.6. That gives us 518 ohm. Capacitive reactance Xc equals to Z sin phi. That is equal to 864 into 0.8. That gives us 691.2 ohm. Capacitance C equals to 1 upon 2 pi Fxc. Using values, we get 1 upon 2 pi into 400 into 691.2. That is equal to 5.7565 into 10 to the power minus 7 farad, or 0.57565 microfarad. Problem number 3. A voltage of 125 volt at 60 Hz is applied across a non-inductive resistor connected in series with a capacitor. The current is 2.2 ampere. The power loss in the resistor is 96.8 watt and that in the capacitor is negligible. Calculate the resistance and capacitance. Let us list the data provided. Supply voltage V equals to 125 volts. Supply frequency F equals to 60 Hz. Power lost P equals to 96.8 watt. Circuit current I equals to 2.2 ampere. Impedance Z equals to V by I. Putting values we get 125 divided by 2.2, that is equal to 56.8182 ohm. We know the expression for power lost P equals to VI cos phi. Therefore, power factor cos phi equals to P divided by V into I. Putting values we get 96.8 divided by 125 into 2.2, that gives us 0.352 leading. Power factor angle phi equals to cos inverse 0.352, that gives us 69.3903 degree. Sin phi equals to sine of 69.3903 degree, that is equal to 0.936. Let us draw the impedance triangle. From impedance triangle we get resistance R equals to Z cos phi, that is equal to 56.8182 into 0.352, that gives us 20 ohm. Capacitive reactance Xc equals to Z sin phi, that is equal to 56.8182 into 0.936, that gives us 53.1818 ohm. Capacitance C equals to 1 upon 2 pi F into Xc. Putting values we get 1 upon 2 pi into 60 into 53.1818, that gives us 4.9878 into 10 to the power minus 5 farad, that is equal to 49.878 microfarad. Problem number 4. An adjustable resistor in series with the capacitance of 25 microfarad draws a current of 0.8 ampere when connected across a 50 Hz supply. We have to calculate the value of resistor so that the voltage drop across the capacitor becomes half of the supply voltage. We also have to determine the power and the power factor under this condition. Let us first list the data provided. Supply frequency F equals to 50 Hz. Value of capacitance C equals to 25 microfarad. Circuit current I equals to 0.8 ampere. Let us find the value of capacitive reactance. Xc equals to 1 upon 2 pi Fc. Putting values we get 1 upon 2 pi into 50 into 25 into 10 to the power minus 6, that is equal to 127.324 ohm. Now let us calculate the voltage drop across the capacitor Vc equals to I into Xc. Putting values, we get 0.8 into 127.324. That gives us 101.8592 volts. According to the problem statement, the voltage drop across the capacitor is half of the supply voltage. Therefore, supply voltage V equals to 2 into Vc. Putting value of Vc, we get 2 into 101.8592. That gives us 203.7184 volts. From the voltage triangle, we get voltage drop across the resistor VR equals to root over V square minus Vc square. That is equal to root over 203.7184 square minus 101.8592 square. That gives us 176.4252 volts. Circuit resistance R equals to VR divided by I, that is equal to 176.4252 divided by 0.8. That gives us 220.5316 ohm. Power consumed in the circuit P equals to I square R, that is equal to 0.8 square into 220.5316. That gives us 141.1402 watt. Circuit power factor cos phi equals to VR by V, that is equal to 176.4252 divided by 203.7184, that is equal to 0.866 leading. Problem number 5. A resistor and a capacitor are connected in series across 150 volt AC supply. When the supply frequency is 40 Hz, the current drawn is 5 ampere, and when the supply frequency is 50 Hz, the current is 6 ampere. We have to find the values of the resistance and the capacitance of the circuit. Let us first write down the data provided. Supply voltage V equals to 150 volts. During case 1, supply frequency F1 equals to 40 Hz. Circuit current I1 equals to 5 ampere. Let us first find the value of the impedance. Z1 equals to V by I1, that is equal to 150 divided by 5, that gives us 30 ohm. Again, Z1 equals to root over R square plus Xc1 square. Therefore, we can write R square plus Xc1 square equals to 30 square. This is our equation number 1. During case 2, supply frequency F2 equals to 50 Hz. Circuit current I2 equals to 6 ampere. Impedance Z2 equals to V by I2, that is equal to 150 divided by 6, that gives us 25 ohm. Again, Z2 equals to root over R square plus Xc2 square. Therefore, R square plus Xc2 square equals to 25 square. This is our equation number 2. By subtracting equation number 2 from equation number 1 we get xe1 square minus xe2 square equals to 30 square minus 25 square, or 1 upon 2 pi f1c whole square minus 1 upon 2 pi f2c whole square equals to 275, or 1 upon 2 pi into 40 whole square minus 1 upon 2 pi into 50 whole square into 1 upon c square equals to 275. Capacitance C equals to 1.4396 into 10 to the power minus 4 farad, that is equal to 143.96 microfarad. During the first case, supply frequency was F1 equals to 40 Hz. We have found impedance Z1 equals to 30 ohm. Capacitance C equals to 143.96 microfarad. Let us determine capacitive reactance. Xe1 equals to 1 upon 2 pi F1 into C. Putting values we get 1 upon 2 pi into 40 into 143.96 into 10 to the power minus 6, that is equal to 27.6385 ohm. Resistance R equals to root over Z1 square minus Xe1 square, that is equal to root over 30 square minus 27.6385 square, that gives us 11.6667 ohm. So today we have solved a couple of tricky numerical problems on series RC circuits. In these problems, the values of capacitance or resistance are not directly given. We have to determine them from the other data provided. I hope you have found this lecture useful. If you have any question or suggestion, please drop it in the comment section below. If you have liked this video, give it a thumbs up and share it with your friends. Thank you.